Thank you, Mr. Chairman. Good afternoon, ladies and gentlemen. First of all, I should say I feel a bit of a fraud talking about raptor banding, because I have to say my experience of raptor banding is fairly minimal. I've been a lifelong student of migration and have been banding birds for about 40 years now. But I haven't ringed or banded all that many raptors. And out of deference to my British heritage, I use the term ringing rather than banding. Our American friends use the term banding, and I'm afraid I'm getting corrupted. I'm starting to use banding as well now, but really I grew up with bird ringing. It's the same thing. To put this in context a little bit, just to mention the history of raptor migration studies in Thailand. Some other speakers have sort of touched on this, and it goes back at least to about 1980, I think, where we first knew that there were movements of raptors coming down the peninsula, because some visiting British bird watchers saw some raptors over the hills. And then, time goes past. 2 or 3 years later, I was lucky enough to attend a meeting of bird conservation societies in Taiwan in, I think, late September or early October. And one of the things we did as a post-conference excursion was to go out and look at the migration of hawks there. And I came back to Thailand a few days later and thought, right, well, let's go down to the peninsula and find the migration here. And with a carload of 2 or 3 friends, we drove down, not sure where to look. And as we thought we would drive towards the hills, and as we were driving towards the hills across the coastal plain, we suddenly found at 7 o'clock in the morning this torrent of raptors flying not over the hills where we expected to find them, but over the coastal plain. But that was as long ago as 1983, and we made a few more observations. But it really took Mr. Chugyat's energies to really get things going here at Chumpon, and Chugyat has been an enormous engine of raptor study in Chumpon. First of all, at Tai Yang district on the outskirts of Chumpon town, and then since he discovered Khao Din Saw a few years ago, and things have really moved on. So Chugyat gave you some background about Khao Din Saw earlier. Let's go on to the first slide. I do this, don't I? Yeah, sorry. Okay, let me see, right? I think... Okay, well, this is a view that you've seen from other speakers' slides. This is a view looking south or southeast from the ridge at Khao Din Saw. Khao Din Saw is a 200 to 300 meter high isolated ridge close to the sea. The surroundings are all, lowlands are all plantation and intensive cultivation, and Khao Din Saw itself is secondary forest and scrub with a sort of a canopy of between 2 to 6 meters above the ground, so it's kind of low growth. And the movement of birds starts quite early in the morning, and as was pointed out by our speaker this morning, Dr. Bildstein, birds do seem to get lift off the coastal edge there, and so the birds in the early morning are coming along the coast and low over the Khao Din Saw ridge, and they're heading south to southwest into earlier in the autumn anyway, a southwesterly monsoon wind. So the birds seem to keep low, partly as a result of that. It was Bob de Candido, together with Chugyat, who are watching birds there, who suggested that it would be feasible to catch migrating raptors at Khao Din Saw with mist nets. And I was initially rather skeptical, but last year, for the first time, we went down there and we put up some nets on the ridge just to see what would happen. And almost immediately, we started to catch birds. This is a mist net set along the ridge. The top of the mist net is something like about 4 meters above the ground, so it's set as high as we can reasonably get it. The nets themselves are about 12 meters long. And this is what the bird sees, the raptor sees, as it's coming over the ridge. Literally, in mid to late September and into early October, there can be tens of thousands of accipiter hawks, Japanese sparrowhawks and Chinese sparrowhawks, moving southwards or southwest over the ridge. And of that great number of birds, a few of them are low enough that they will pass at net height. And we try to put nets in gaps in vegetation, natural gaps in vegetation along the ridge. So this would be the bird's eye view. If it doesn't, hopefully it doesn't see the net. The mist nets are fine, nylon material, and the birds will choose a gap, go through the gap, and if a net is set in it, then you hope you're going to catch them. We've been using, for raptors anyway, about 5 12-meter nets with a mesh size of 3 to 5 centimeters. These are made by Spidertech. But we've also got some smaller mesh nets that we use for catching passerines, and these will also catch raptors as well. And this is a male Chinese sparrowhawk. This is how the bird looks when it hits the net. The birds are coming from the north, so they hit the net on the north side of the net, and are immediately pocketed. We check the nets at least every 20 minutes. We check them as often as we can. And then the bird is extracted, put in a bag, and taken back to the ringing station. And because the nets are set high, we have to use a furling stick with a long stick with a hook on the end, which we can use to bring the net down. This is my colleague Andy Pierce here, who's using a furling stick to lower the top shelf of the net so we can take the bird out. We try to work in pairs because sometimes you might need more than 2 hands to accomplish the task. And this is a smaller mesh net, 18 meters long, set in the vegetation rather than in a gap for smaller land birds as well. Because we figure if we're catching raptors, we should also monitor other smaller migrants as well. And I must stress, the catching effort up to now has been really very small. It amounts to no more than 10 days of full-on catching. And since I prepared this slide, we've had another couple of days, and my colleagues Andy Pierce and Wangwan Sankametawi from Konkan University, and Andy Pierce is from King Mongkut's University of Technology. They're up on the mountain now with nets up, and they're working all day today. So we only had about 6 days last year to catch birds, and we've only had about 4 days this year. So, as I say, the catching effort's been really small up to now, but our totals of birds so far are 46 Japanese sparrowhawks, 26 Chinese sparrowhawks, and a shikra caught by my colleague Dr. Kasset also last year. This is the ringing station. This is Sala number 2 on Kaudinsa, so it's really an observation station which we've pressed into use on weekdays when there aren't too many visitors around in order to ring birds. And you will recognize Jugyat here. He's processing a sparrowhawk, and this is my colleague Andy Pierce writing down the data. So we have about 300 meters, I think, between the top net and the ringing site. All the processing of birds is done on the spot, pretty much. And the rings we use are rings supplied by the Department of National Parks, Wildlife and Plants Conservation, which is a partner of this project. We have permission from the DNP to do this work, and they're UK made by Porzana. And here's Jugyat fitting a ring on a Chinese sparrowhawk. And here he's measuring, he's looking at wing formula, which is something I'll explain in due course. This one is a Japanese sparrowhawk. And this is part of the processing of the bird. The bird is being weighed. This is the easiest way to weigh a bird. You the plastic cup here is zeroed on this balance, which is supposedly will weigh to the nearest 0.1 gram, but depends how hard the wind is blowing. But it is pretty accurate. So the bird is immobilized like this. It can't flap its wings, and it just lies there quietly while you weigh it. And we record, first of all, species, age, sex, wing length, maximum chord. Wing length gives you the best and easiest measure of the body size of the bird. That's really why ringers measure wing. And other measurements like tail length, length of bill from the bill tip to the cere, tarsus, weight. We look at molt status, because typically birds have a mixture of old and new feathers. And then we look at fat and muscle condition, and we also, when we remember to do it, we look at the crop, that is the throat of the bird, to see whether the bird has fed recently. And also we've been measuring, looking at wing formula, just recording relative lengths of the primaries, because most of the field guides give, or those that deal with birds in the hand at all, give wing formula as a means of separating particularly immatures of sparrowhawks. And we try to photograph every bird. If we're not inundated with birds, we photograph every individual, so we have a good record. And the data is put into a database called IPMR, which records all the parameters of the bird, and is then submitted, is held on file here with Chugit at the Chumpon Raptor Center, and it also goes to the Department of National Parks as well. Now let's look at the birds themselves. We have pictures of Japanese sparrowhawk here, male, upper parts and underparts on the left, and female upper parts and underparts on the right. I've labeled each bird with this is the ring number. Each bird has got an individually numbered ring, so I know which individual is shown in the photographs here. But you see the features of the birds immediately here. The distinctly barred underparts on the female. Female's larger than the male, yellow iris. Male has a red iris. And this is kind of scarcely barred, just vague barring, but it's kind of peachy, vinous colour on the underparts of the male. And the male's, of course, a grey above, female's brown above. So. And here we have Chinese sparrowhawk, again, male on the left and female on the right. And again, you see the dimorph. Oops, what have I done? I'll go back. Right, yeah. You see the iris colour. It's kind of dark crimson red, wine red in the male, and yellow in the female. One feature which immediately stands out, but is this kind of luminous orange yellow cere of Chinese sparrowhawk in all age and sex classes. This beautiful orange yellow cere, which is a brighter colour than the sort of duller lemon yellow cere of Japanese. And perhaps not so easy to see in these slides, but you will see in later slides, Japanese sparrowhawk has a yellow orbital ring in all age and sex classes, whereas in Chinese the orbital ring is grey. And of course you can see very easily here the difference in underwing pattern with the prominent black wing tips and whiter, less barred and unmarked underwing coverts. So when we initially started to catch, we thought, well, if we catch any at all, we'll catch Japanese because they come through low. whereas the Chinese tend to be higher and come across in flocks, so they're obviously not feeding. Some Japanese, we think, are hunting as they're coming, so you expect them to be lower, and you expect you might have a greater chance of catching them. But we were so excited when I think it was the first or second day, we not only caught Japanese, but we also caught Chinese as well. Because when we started catching sparrowhawks, we thought we were going to have to use baits to bring them down, live bait. We tried chicks in a little cage which we put up by the mist nets, and we looked after these chicks very carefully and made sure they had food and drink, and were very careful of their health, and we were hoping they would actually attract sparrowhawks to come down. But in fact, after the first couple of days, we found that we didn't attract any birds by using the chicks, and we were catching birds without the chicks. So okay, so we just put up nets and we don't use baits. Okay, and now I move on to juveniles of the two. So again, Japanese on the left, Chinese on the right. Again, you see the difference here in the cere color and the difference in the eye color. So the lemon yellow orbital ring of Japanese compared with the grey orbital ring of Chinese. There seems to be some individual variation in head pattern. Some Chinese have quite dark heads, some have more of a pale supercilium, some have lesser supercilium, and I think this is sort of typical in that Chinese tend to have more denser markings on the breast and throat. What struck us right away as soon as we started to catch adult male Japanese sparrowhawks was that there's individual variation in the color of the iris. You see how the bird on the left has this light orange scarlet iris, whereas the bird on the right has a much darker crimson red iris. And we think this may be age related. We assume that birds with darker iris, oops, I've done it again. We assume that birds with darker irises are older birds, but we don't really have any evidence of this. There may be something in the literature. Perhaps Dr. Yamazaki knows. I'd be very interested to talk about this later. This is a particularly interesting Chinese sparrowhawk. We think this is a second calendar year bird, and there's a bird that hatched in 2011. These, you see these feathers here, these brown feathers, these unmolted secondaries, and the outermost primary here. These are brown, retained juvenile feathers. And instead of having the dark crimson eye of the adult Chinese sparrowhawk, you see this bird has a bicolored iris. It's got a yellowish, some yellowish on the outer ring of the iris, and redder inside. So we think this is a second calendar year bird. So it would be about maybe 15 months old when we caught it in September. That's the tail pattern of the same individual, and it looks like all the tail feathers are renewed. But typically, even full adults will have a mixture of old and new primaries and secondaries. You see, here's another Chinese. You see, this has the dark vinous iris. In fact, this slide, you don't really see any red in the iris. I think that's just an artifact of the color reproduction here. But the iris in an older male Chinese sparrowhawk is dark vinous like this, with a bit more of a red tinge, and you can see there. So this is thought to be a third calendar year bird or older. It's got no retained juvenile feathers, but maybe you can just see it's got a mixture of old and new primaries. Maybe hard to see, but these three feathers here This is the innermost primary. It starts there. The birds have 10 primaries. So you 1, 2, 3, 4, 5, 6, 7, 8. I guess 9, 10 is up here. So these inner primaries here have been renewed. Whoops, this is not really. I guess I didn't. These inner primaries here have been renewed, and these are old and worn, unmolted primaries. You see how worn and abraded the edges of these primaries are. So typically, adults or older, any non-juvenile Chinese and Japanese sparrowhawks that we catch will typically have a mixture of both old and new primaries and secondaries in the wing here. Okay. This is called arrested molt. Okay, here's what we think is a second calendar year female, where you can see a little bit more clearly. These 6 new primaries here, you see there's the innermost primary. That's primary number 1 if you're doing molt. 1, 2, 3, 4, 5, 6. These have been renewed on breeding grounds. Maybe they were renewed actually as the bird was in the process of breeding. And then these 4 here are old, unmolted outer primaries. And then the secondaries, the secondaries start here. Here's the outermost secondary. This has been renewed, but then these are old, unmolted feathers. Okay. I think the tail of this one is all new. I'm not sure about the age of these 2 here without going back to look at the original data sheet. And I'll just say something about molt, because many of you may not know so much about it, but it's something that bird ringers like myself like to collect information on, because molt is one of the key events in the life cycle or the annual cycle of the bird. I mean, the 3 events really that are of importance to a bird that are energy demanding are breeding, migration and molt, and these 3 events have to somehow be fitted into the annual cycle of the bird. They all demand significant food resources. And what happens with molt, this is actually a wing of a passerine bird, and this shows early molt, mid molt and late molt. What happens with molt is that the feathers are replaced gradually in most birds so as not to impair flying ability, and they start with the innermost primary, and the primaries then are shed one by one as you go from the inner wing towards the outer wing. So this bird has just started here. Primaries, the first primary and the second innermost primary have just grown part ways. These are still old, and this is the molt score that the biologist recording the molt would record. The feathers which have a 0 score are old. And then as molt progresses a little bit further, about halfway through the secondary, about halfway through the primaries, then the outermost secondary is dropped. You see here? And in the course of molt, as I say, primaries are molted from inside outwards, we would say centrifugally. But secondaries are molted from the outside in, so centripetally. And so as primary molt progresses, then secondary molt starts. And secondary molt is typically staggered after primary molt, but the molt of the wing, primaries and secondaries, usually finishes about the same time. Now in the case of a small bird like a warbler, maybe it only takes 30 to 60 days for the bird to renew all its feathers. In the case of resident forest birds in Thailand, they take longer, maybe 50 to 90 days. And in the case of larger birds like sparrowhawks, because the feathers are bigger, it takes longer for them to grow. And I think the duration of molt in northern sparrowhawk, which has been studied in Europe, is about 4 months. I'm not sure what's been published on the molt of Japanese and Chinese sparrowhawks, but what we are seeing here is arrested or suspended molt. The birds only molt some of their wing feathers before it's time to migrate. So when they arrive with us, they have a mixture of old and new feathers. And what is really interesting about, these days with the fantastic quality of digital photographs that Chugit and Bob and Cheyenne and others are getting, is that it becomes possible to study molt without even catching the bird. For those who are interested in doing it, as long as you know you have different individuals in your photographs, you could actually do a molt score for each individual bird from a photograph like this. This is one of Bob's pictures of a Chinese sparrowhawk, and it looks like all the primaries here are probably all new actually, but it's got some retained unmolted secondaries here. So by judicious use of digital photographs, I think we can collect a lot of information on molt, and it's something that everybody who takes photographs of birds can share in. Makes it very interesting. You don't have to be a ringer to collect meaningful biological information on birds. And this is just a graph to show there seem to be some differences in the molt strategy of the Japanese and the Chinese sparrowhawks we've handled. This is the number of old unmolted primaries that they have, and you see that many of the Japanese sparrowhawks have got, they've only molted 2 or 3 primaries. They've got 8 to 10 unmolted primaries. In fact, most Japanese sparrowhawks that we're handling, most non-juveniles, have got about 8 unmolted outer primaries. But when you look at Chinese, we don't have quite as much data, but it looks as if more of the Chinese sparrowhawks have actually molted more of their primaries. They have fewer unmolted primaries, which is interesting, and it may be related to the well, it's presumably related to the conditions on breeding grounds and how far they have to fly. I mean, Chinese sparrowhawks are not as northerly distributed as Japanese sparrowhawks. Maybe they have actually a longer season, which gives them more time to molt feathers, more feathers on breeding grounds. Here's just some figures, some of the preliminary data we've been collecting on birds. This is just to show wing lengths of, oops, here we go again. Wing lengths of different age classes: adult female, adult male, juvenile female, juvenile male. This is wing length. As you already know, as one earlier speaker said, talking about the reversed sexual dimorphism in most birds of prey, females are usually significantly larger than males. And in Japanese sparrowhawk, the sexual dimorphism is extraordinarily large. The average wing length of an adult female Japanese sparrowhawk is over 190 millimeters, whereas males are much smaller. I mean, only 167 millimeters. And when we look at the juveniles, we can also see, okay, it's just reflected in the juveniles as well, that we don't have a large enough sample to know whether juvenile females are significantly lighter than adult females, but we would expect them to be. One other thing I put on here is a measure of tail and wing ratio. One thinks of Japanese sparrowhawks being short-winged and Chinese sparrowhawks are being much longer-winged, but there's not that much difference in the wing ratio. I mean, there obviously is some difference. The tail to wing ratio in a Japanese sparrowhawk works out about 0.72. Here are the equivalent figures for a Chinese sparrowhawk, and you see the tail wing ratio is smaller. They have a proportionally longer wing relative to the tail. Again, there's sexual dimorphism, but the sexual dimorphism is much less pronounced in Chinese sparrowhawk than it is in Japanese sparrowhawk. I mean, Not much difference, but some. So when we actually catch juveniles, as far as we can tell, we don't know how to sex juveniles because they're pretty close. Females and males are quite close in measurements. It looks like, based on this, that since the mean measurement of juvenile wing length and adult male wing length is exactly the same, maybe all we've caught so far, all the juveniles are probably all males, but I mentioned differences in wing shape, and wing shape is reflected in something called wing formula. Basically, birds with a longer, more pointed wing, the longest primary will be closer to the leading edge of the wing. This is the folded wing of a Japanese sparrowhawk, and the longest primary in all the Japanese sparrowhawks we handle is primary number 4. Okay, the fourth outermost primary is always the longest in all 41 birds for which we have wing form information. And in the majority of birds, the second longest is P3, the third outermost primary, and the third longest is usually P5. But there are some birds in which a minority in which P5 is actually longer than P3. This is not really of much relevance to you probably, but it's just an indicator of wing pointedness, that the closer the longest primary is to the leading edge of the wing, then the more pointed the wing is in pretty much all birds, not just raptors. And this is the wing of a Chinese sparrowhawk, and in most Chinese sparrowhawks we've handled, the wing point is P3, the third outermost primary. Okay, so it's a more pointed wing. The wing point, the longest primary, is closer to the leading edge instead of P4, as in Japanese it's P3. But there were a couple of Chinese we handled in which the wing point was not P3 but was P4. So. And just so we could see something at the measurements of these birds, this again brings us back to marked sexual dimorphism in Japanese sparrowhawk. The squares are the respective sexes of Japanese sparrowhawk, and the circles are respective sexes of Chinese sparrowhawk. And you see how far apart, this is the wing length on the horizontal axis, and this is tarsus length on the vertical axis. You see how far apart the males and the females are. You know, you almost don't have to take a Japanese sparrowhawk out of the bag. As soon as you put your hand in, you know from its size if it's a male or a female, because the size difference is so outstandingly pronounced. In the case of Japanese sparrowhawk, as I've already said, that the sexual dimorphism in size is not as pronounced. Okay, females are, of course, bigger than males, but you know they're fairly close to each other. But the other thing that's interesting about this is look how different the two species are in their length of their tarsus. You see how the tarsus length of Japanese sparrowhawk is about 45 to 55 millimeters long, whereas the Chinese are much shorter-legged birds. And this is something that you rarely get a chance to look at in the field, but it presumably reflects the lifestyle. I don't quite know how it's applicable to the lifestyle, but we know that Japanese sparrowhawks feed a lot on birds, and Chinese sparrowhawks feed more on frogs and insects and things, so presumably the shorter leg is related to their biology somehow. And when you plot, this is a plot of weight against wing length, you see how, again, the squares are Japanese and the circles are Chinese. And I also put juveniles into the mixture here, and you see also how juvenile males cluster with adult males and juvenile females cluster with adult females, how easy it is to separate juveniles on size. And just these are weight differences. You see again with Japanese sparrowhawk, the male is half as heavy again as the female is half as heavy again as the male. The average weight of female Japanese sparrowhawk is 150 grams. Average of a male is about 100. But with Chinese, the two sexes are not much different in weight. And this is sort of relevant because if one is interested in satellite tracking these birds, one has to bear in mind that, you know, the Chinese sparrowhawk is a pretty light bird, so you're going to need a very light, highest technology satellite transmitter to put on this bird. I'm not sure how heavy a Eurasian cuckoo is, but Eurasian cuckoos have been satellite tracked from Europe to Africa quite successfully. So well, maybe it'd be possible to use a similar size transmitter on a Chinese sparrowhawk. I mean, I guess Amur falcons have now been satellite tracked across the Indian Ocean, but an Amur falcon is a significantly heavier, bigger bird than a Chinese sparrowhawk. I think they weigh about 200 grams. So so basically at Cowden Saw, my raptor experience at Raptors in Hand is limited to Chinese and Japanese sparrowhawks. I have caught shikra elsewhere. This is a juvenile shikra that was caught on migration at Summit Sakon near Bangkok. I'm surprised looking at this. Mortan alluded to differences in underwing covert pattern between juvenile shikras and juvenile Japanese sparrowhawks. I'm looking at this. Well, I'd like to know more about this because I look at how evenly spotted, you know, this young shikra is relative to the Japanese sparrowhawks, which are also pretty heavily and evenly spotted. And some of the pictures of shikras that were shown, juvenile shikras that were shown earlier, you know, didn't have this pattern of spotting. They had larger and sparser spots, so there seems to be individual variation. Yeah, but this is undoubtedly a shikra. You see it has a grey orbital ring. It doesn't have a yellow orbital ring. So it's also quite large. And this we think is a Besra. This was caught this was actually caught in Kanchanaburi in western Thailand in a piece of secondary forest on the university campus. But I was puzzled by this bird and consulted with Cheyenne about it. This has a yellow orbital ring, and it's very interesting, gingery, buffy wash on the breast. A wing form will also fit. A wing form and measurements fit Besra. So it's certainly a bird we'd like to catch more of. But I think we'll be unlikely to catch them at Cowden Saw because there were very few coming through. Interestingly, something you notice in the hand, and I'm sure all the raptor biologists are familiar with this, is how raptors have a distinct bony brow above the eye, which you don't see in many other birds. The brow sticks out above the eye and presumably shades the eye to some extent from solar radiation coming from above. It's probably important for a bird that is in open conditions so much of the time. I have caught one or two other exhibitors. This is a resident taxon of crested goshawk. This is from Khao Yai, where they actually nest. They're quite a bit larger. But it would be very nice to catch some other raptors at Cowdensaw. I'm sure we have a chance of things like black baza and grey-faced buzzard, who knows, you know. So, we've had a great deal of help at Cowdensaw, not least from the Klongsang Wildlife Research Station of the Department of National Parks. This is the assistant there from Klongsang with a female Chinese sparrowhawk in his hand, and of course you know, Bob De Candido, who's there counting all day long, and Marty Siponen from Finland, you know, many of whose pictures Tugit showed. You know, they also have been delighted to participate in the ringing as a bit of light relief from counting birds from time to time. And we've had other volunteers at various times, and you know, we're always happy to have assistants to help put up and take down nets and handle birds and so on. And as I sort of indicated, you know, I'm by no means a raptor person. I enjoy raptors, as indeed I enjoy all birds. You know, but if we're taking time to catch and study raptors at Cowdensaw, we have there's a lot of other things we can do as well in between the raptors, and it's an excellent place for studying migration of other birds. Obviously, the visible migrants, such as the bee-eaters and drongos, have already been the subject of papers by Tugit and Bob and others. You know, but there are many other less obtrusive migrants that are coming through, and I think the potential for adding greatly to our knowledge of migration in peninsular Thailand at Cowdensaw is huge. This is everything we've caught up to now at Cowdensaw. The species I've outlined in yellow, these are the resident birds. They include emerald dove, black-crested bulbul, striped-throated bulbul, orange-bellied flowerpecker, little spider hunter. But you know, it's quite surprisingly how depauperate in resident birds Cowdensaw is. It's just scrub forest. But even though it is scrub forest, I thought there would be more there than there is. You know, but it more than makes up for this in terms of diversity of migrants. You know, we've caught species like blue-bearded bee-eater, brown shrike, crow-billed drongo, and I'm surprised how many Asian paradise flycatchers we've caught. In the Asian paradise flycatcher is a species that has both resident and migrant populations, and almost all these we've caught are Chinese migrants, the race Insei. We've caught red-rumped and barn swallows. The top scoring passerine so far is eastern crowned leaf warbler here, Philoscopus coronatus. You know, that goes through in September, but it's pretty much the migration of that species is over now. But now we're getting more pale-legged leaf warblers coming through. These are three Philoscopus you can see up close in the hand. This is eastern crowned with a yellow vent, nicely green above and very white belly. Arctic warblers we haven't caught so many of, but we've caught a few. Well, right now, pale-legged leaf warbler is the one that we're catching most of. And there aren't all that many records of pale-legged leaf warbler for the peninsula. It's regarded as being scarce down here, but we're catching quite a few at Cowdensaw. And then this is a species known as variously as plain-tailed warbler or Alström's warbler. It's one member of a 6-species swarm of sibling species that all are incredibly similar, and they're most easily told on call note. If you know the calls, you can separate them. But until we started netting at Cowdensaw, there was only one record of this taxon for the Thai Malay Peninsula, and that one record was my own site record in the field from 20 years ago. You know, and we've now caught 6 of these in just a few days at Cowdensaw. So, you know, as I say, the potential for adding to information on the status of birds from Cowdensaw is very great. And you know, again, I know you're raptor people, but please indulge me a little bit while I mention the passerines that I like. I'm very much interested in Asian paradise flycatchers, and here you see 2 different taxa. This is the migrant race Insei, which is the Chinese breeder. This is the resident Southeast Asian breeders, Indochinensis. How do we actually know, how do we separate these two? Well, the easiest thing is you see how in the local resident, the throat and breast are evenly pale grey, whereas with the Chinese migrants, they always have a darker throat than they have breast. Okay? The other interesting thing is that the males tend to be a different colour. In this taxon, it's a darker, more coppery red on the back. Or in this taxon, it's a lighter red. And we can also, by dint of handling many more of these birds at Cow Din Saw than I've caught anywhere else, we're also able to figure out how to age them. You see how the bill in these two is kind of pinkish; it's not blue. And this indicates that these are both, you know, birds of the year. They're first-year birds, whereas older birds, second-year birds or older, have a blue bill. Okay, so actually, yeah, that's an older. That's at least a second calendar year bird. No, but this is a photographs of the same first calendar year bird, and this is a first calendar year bird. So, you know, the sky is the limit almost as far as, you know, studying migration and aging and sexing and racial variation in birds is at Cow Din Saw. There's a lot to do. And so what about the future? Well, clearly the most important thing we need to do is to actually spend more time on the mountain. Now, bearing in mind that at the time I prepared this presentation, we'd only spent 10 days split over 2 years there. So we actually need to be there catching birds for longer periods and using more support, more people. And we'd like to extend the range of raptors caught, and maybe this can be done by diversifying catching techniques. It would be helpful to have one or two people who've used and can advise on other techniques which might enable us to sample a wider range of species. You know, maybe we should go back to trying bait luring of one sort or another, maybe with, you know, balchatri noose traps that can sometimes bring birds down. Now, perhaps by playing the distress call of a bird through a loudspeaker near a net, you may attract raptors to come down. You know, who knows? And also, it's a great place to you know, to train other ringers. You know, it's in most Asian countries, it's not that easy to get permission to even ring birds. Countries like the US and most European countries have organized ringing schemes where volunteer banders can do a lot of banding. They can operate. Sometimes they even buy their own rings using their own funds, but they send the data to a government or other center where it's processed and held. And in order to get more information on birds, in order to be able to monitor birds, monitor their survival, their conservation, ecology, and so on, you need to be ringing large numbers of birds all the time. This is a good way of monitoring populations. It's a way of monitoring how populations change year to year. It's a good way of monitoring productivity and survival and so on. But this can't be done by a small number of professional government biologists, you know, with inadequate resources. But it can be done if you have a sophisticated ringing scheme which involves both government and non-government people and volunteers working together. So we hope that in Thailand and other Southeast Asian countries in years to come, it will be easier for more people to participate in ringing activities and contribute data. In the immediate future, one of the things that we probably ought to be doing is we need to investigate satellite tracking and how this might be used to mark you know, and track some of the raptors that are coming through Cow Din Saw. As Chuket already indicated, probably our first target species for this will be Chinese sparrowhawk. Okay, well, I think I'll finish here. I'd like really to thank all the many persons who have, you know, made the effort at Cow Din Saw possible, and particularly I'd like to mention these to Ed Pease and Nurak Isra-Sena, who have both been benefactors of the Chumpon Centre. I think the biggest supporter of the Chumpon Centre has actually been the government. Because of Chuget's excellent contacts, he's actually been able to get significant government funding for this, which is all credit to the Thai government agencies involved. But in addition to that, Ed and Nurak have also provided significant support for work going on here, and it's particularly important that I should mention this now because Mr. Nurak is critically ill at the moment, and we're all praying for his recovery, but he's not in good shape. And of course, most of all, the key person who really made all this happen is Palat Bu, Khun Chuget himself, and he's been pushing this for over a decade now, and really all credit to him, because without his outstanding efforts, none of this would have happened. So, okay, thank you all. Thank you.